Dear students, today we shall be talking about the fins. We shall be talking about the types, modifications, and functions of fins. Before proceeding, it is my request to you to like and subscribe my channel BioLearning. So, talking about the fins, we say fins are membranous extensions of integument that are supported by muscles and fin rays. So, when we talk about the fins, we are talking about the locomotory organs of the fishes, and these are membranous extensions of the integument that are supported by muscles and fin rays. So these supporting rays may be bony, they may be cartilaginous, they may be fibrous, or they may be horny. So these supporting rays may be bony, cartilaginous, fibrous, or horny. So these are the chief organs of the locomotion in fishes and are devoid of coelom. So they are not having any coelom. So fins help in swimming and maintaining balance of the body. So their main function is to swim and to balance the body. And these are also helpful to identify the fish species. So fins are very helpful in identifying the fish species. Before we move, let us have a little bit idea for those who are new to this very subject, that this is the position of the fins. So this on the dorsal side, this is the dorsal side of the fish, and this is the ventral side of the fish. So the fins on the dorsal side, they are called the dorsal fins. These can be one, these can be two or three in number, and many times if they are more in number, two are more than two dorsal fins, we also call them as the adipose fins. And this very dorsal fin, this is single, that is, we say that this is unpaired single. We call such fins as unpaired. So you have to keep in mind that there are some fins which are paired and there are some fins which are unpaired. So dorsal fin, caudal fin, and anal fin, we call them as the unpaired or median fins. Then we do have the two pairs of the fins, that is pectoral fin. This is the pectoral fin just near the gill. We call it the pectoral fin, and other are pelvic fins. The other is pelvic fin. It can be in the abdominal region, it can be in the thoracic region, depending upon the species and the environment they live in. So when we talk about the structure of the fins, we see that the fins, they are of different shapes and sizes. The appendages of the fin that comprise of the fins and cerci are the flaps of the flesh. So when these very fins, they are in the form of the flaps of the flesh, we call it as a cerci. We call it as a cerci, or the flaps of the flesh, such as you see here. These are actually the flaps of the flesh here, and these attain extreme development in sargassum fish, that is Pterophrinae, and the leafy sea dragon. It is the leafy sea dragon, that is Philopteryx. It looks as if these are not the fins, but these are the leafy appendages. They are having the different kinds of the modification, and these very fins can be of different shapes and sizes as well as the structure. Two types of fins are there in fishes, and fins are one of the most distinguishing features of the fish, and they have several different forms. I told you earlier that they can be unpaired or median fins. So unpaired or median fins and paired lateral fins. or paired lateral fins. So dorsal fins, they are unpaired. Caudal fin, they are unpaired. The anal fin, that is unpaired. We call them as the median fins as well. Median fins as well. And the other fins which are in pair, that is pectoral and pelvic, we call them as the lateral fins. Lateral paired lateral fins. So the fins near the gills and the fins in the abdominal portion or the thoracic portion, they are two in number and hence they are paired, whereas the dorsal fins, caudal fin and the anal fin, they are not in pair. We call them as the median fins. Then we shall be talking about the unpaired or the median fins. First of all, they develop in the median axis. The first thing is that they develop in the median axis and they may be rayless fatty adipose fin as in the case of trout such as Salmonidae, or fins reduced to few disconnected spines as in the case of sticklebacks. So they may be off fins which are reduced to a few disconnected spines such as in the case of sticklebacks, or they may be rayless fatty adipose fins such as in the case of trouts. The anal fin may be modified into intermittent organ. The gonopodium for the use of copulation in the case of live bearers. So there are some fishes, we call them as the live bearers such as guppies, which belong to family Poecilidae. So in them what happens, this anal fin becomes elongated and it acts as a gonopodium and it helps in the copulation as well. And then median fins, they are single in number which run down the middle line of the body. And in fishes, median fins are dorsal, caudal and anal fins. So dorsal, caudal and anal fins, they are unpaired and we call them as the median fins. So dorsal fins, they may be in a series or reduced or absent. They may be in series, that is 1, 2 or 3, or they may be very much reduced or absent in some cases. They are mostly 1 or 2 in number, but in some cases they can be 3 in number in exceptional cases. They are present along the mid dorsal line. Now talking about the ventral anal fin, they are present behind the anus or the vent or cloaca. So if this is the belly of the fish and this is the anus or cloaca, the fins which are just behind the anal portion, we call it as the anal fin. So anal fins may be absent especially in the bottom dwellers. So in the case of bottom dwellers, anal fins are mostly absent because now what is the reason behind? Because the bottom dwelling fishes, they have to stay at the bottom and this can prove as a hindrance in them. So talking about the tail or caudal fin, they are present around the tip of the tail. So around the tip of the tail, the fins present, we call it as the caudal fin. Now let us have a little bit idea about the paired lateral fins. So we shall be talking about those very fins which are in pair, and that is pectoral and the pelvic fin. So paired fins are pectoral and the pelvic, which are arranged in pairs. They are homologous to the arms and legs. So the structures, we call them as the fins in the case of fishes. That is the pectorals and the pelvics. They are equivalent to or homologous to the human arms and the legs. Pelvic fins are called thoracic. So now look here what I was telling you, that they may be thoracic when placed, they may be abdominal when in the abdominal portion when situated just in front of the anus. Now one thing is there. What is the difference between the anal fin and the abdominal fin here? Anal fin is always present behind the anus whereas just in front of the anus it can be the pelvic fin. Now pelvic fin are of different kinds. If they are just in front of the anus, we call them as the abdominal. If they are just away from the anus, we call them as a subabdominal. And the pelvic fins, when they are placed below the just below the pectoral fins, if they are just placed below the pectoral fins, we call them as the thoracic. And one more modification is there, that when they are placed just near the gills, we call them as the jugular. So you have to keep in mind that the pelvic fins, they are of different they have the different names based on the position. If they are just in front of the anus, they are abdominal. If they are just far away, little bit away from the anus, we call them as subabdominal. If they are just below the pectoral fin, we call them as a thoracic. And if they are just near the gills, we call them as a jugular. And in some cases they can be absent as well. So both the unpaired median and the paired fins are supported by the skeletal rods. We call them as the radials or the dermal fin rays. Now, for example, in the case of when we talk about the tetrapods, we do have the carpals, metacarpals, phalanges. But in the case of the fishes, they are supported by the skeletal rods. We call them as the radials and the dermal fin rays So the support provided to the lateral fins or the paired fins, that is by the radials and the rays. A great variety of the fins is observed in the case of fishes, and the diversity of the fin system in fishes is due to their adaptive responsiveness. So this all diversity is because of their adaptive responsiveness, that is, they have modified themselves according to the environment they live in. Now talking one by one, first of all we shall be talking about the dorsal fin. So this type of fin is located, I was telling you as well, that the type of the fins which are located on the top, that is on the dorsal side or on the back of the fish, and which helps the fish to take quick turns or stops. Now, if somebody asks you that what is the main function of the dorsal fin, it is to have the quick turns or stops. So it helps against rolling. So it does not allow the fish to roll, otherwise fish may roll. So it helps to maintain the balance. In fish there are three distinct dorsal fins, such as proximal, it can be proximal, it can be central, and it can be distal. So I was telling you about the three kinds of the dorsal fin. They can be proximal, they can be central, they can be middle. So some fish have two dorsal fins, where the central and the distal fins are combined together. Many times the central and the distal fins, they are combined together. For example, in these very fishes you are seeing here, that herein you are seeing two dorsal fins. Herein you are seeing three dorsal fins. Herein you are again seeing two dorsal fins. But it is only, they can be proximal, central, or distal in position. So you are seeing here, you are again seeing here that these are the dorsal fins in the case of fishes with different types. Now, what are the different types of the dorsal fins? They can be single, they can be pointed, they can be split, they can be spine triangular, they can be trigger shaped, they can be trailing type. So if they have the only one dorsal fin, we call it as a single, and if it is pointed, we call it as the pointed one. And split, many a times the dorsal fins, they are split, that is one end is totally different from the other, but it is the dorsal fin which is looking dual in shape, we call it as the split. Then we do have the spine triangular. we do have a spine. This is called the spine, just spine like and triangular in position, triangular in shape. We call it as a spine triangular. Then the dorsal fin just looking like the trigger of the gun. We call it as a trigger dorsal fin. And the dorsal fin which is having a long ray and which is trailing behind the fish, we call it as the trailing dorsal fin. Then we do have the different kinds of the modifications or different types of the pelvic fins based on their position. So in fishes, a pair of pelvic fins are present which are located ventrally and behind the pectoral fins. So we do have the pelvic fins which are located ventrally below, just below, which are below the pectoral fins. Generally, fish use pelvic fins for moving upwards and downwards. Now, keep in mind that what is the main aim of the pelvic fins? It is the moving upward and downward. So the movement for the upward and the downward, it is generally carried out by the pelvic fins. The pelvic fins are lacking in lampreys and hagfishes. Hagfishes and the lampreys do not have the pelvic fins. And it is also lost in anguillidae, that is a snake-like fishes, that is eels. In them also the pelvic fins, they are not present. So when we talk about the sharks, in sharks and some relatives, they are modified into claspers. So in the case of sharks, they are modified into claspers, and keep in mind that these very claspers, they are used in the reproductive activities as well. They help in the release of the gametes as well. Now then we do have the cling fishes, are the sucker belly loaches and certain other fishes. The pelvic from the part of a hold fast organ that resembles the suction cup of the belly. So in some of them, they act as the suction pumps. So you have to keep in mind that in certain hill stream fishes where the flow of the water is fast, these very pelvic fins, they have also the function to act as a hold fast organ. So they help in the clinging to some of the substrate in the hill streams. So what is the main function of the pelvic fins? It is the moving upward and the downward. So in some fishes it is lost, such as lampreys and hagfishes, and in the case of anguillidae. So the pelvic fins, they are very substantially in position and they have adaptive modification. Their support is by the pelvic girdle, so they get support from the pelvic girdle, and they are anchored in the belly musculature. In soft-rayed fishes, that is malacoptergians, the pelvic fins are abdominal in position. So in the case of malacoptergians, the pelvic fins are abdominal in position, and in the case of clypeaids and salmonids and cyprinids, so we are talking about these very fishes wherein the position of the pelvic fin is abdominal. So but they are also situated arterially just below the pectorals in the case of acanthoptergians, or even under the throat, such as which I was talking earlier about the jugular position. So in the case of Blannies. So herein you are seeing that the position of the pelvic fins, even this is the abdominal position, this is the thoracic position, and herein you are seeing this kind of position. This is jugular position. So this is again subabdominal position. So it is based on the where they are present. So in some fishes, these are situated in front of the pectoral fins, such as cod family. They are situated just in front of the pectoral fin, and this type of the fins, helps in the stability and slowing down of the fish. So they help the fish to slow down. Then we do have the anal fins. We also call them as the cloacal fin, which is located on the ventral side just behind the anus. Now, the only difference between the pelvic and the anal fin is that the anal fin is behind the anus, whereas the pelvic fin is in front of the anus. It supports the dorsal fin, so it gives support to the dorsal fin and stabilizes the fish during swimming and controls the rolling motion as well. Then we do have the pectoral fin. The pectoral fins are located on both sides. So these are located on the both sides, usually just behind the operculum. And it is homologous to the tetrapod's forelimbs. So this is homologous to the tetrapod forelimb, and it provides support during swimming. It creates dynamic lifting. So important feature of the pectoral fin is that it creates dynamic lifting force and helps the fish to turn left or right. So it is the fin which is responsible for turning the fish right and left. Then we do have the this very fin. It is ordinarily present in the fishes. The pectorals are wanting in some kinds such as lampreys, that is Petromyzontidae, hagfishes, that is Myxinidae. They are greatly enlarged in the soaring flying fishes. So in these very flying fishes, what you are seeing, that they are extremely large enough so that it helps in the gliding of these very fishes. When they come out of the water, they can take a leap and they glide up to a certain distance, and this is the fin which is responsible for the gliding of this very fish. We call them as the flying fishes, and it belongs to the family Exocetidae. So the genus is Exocetus, and the flying characins, which belong to Gastropelacini. Then we do have some cling fishes. So you are seeing here that these are some of the hill stream fishes which have such a kind of adaptation, such as Glyptothorax, Glyptosternum, or the sucker bellies, which belong to the loach family. So in them, what happens? The pectorals serve as a part of the ventral holdfast organ. So this very fin, it helps. You are seeing here that this very fin is now modified so that it has some clinging hooks so that it can hold itself to the substrate or the stones, so that it cannot get washed away by the flow of the water. So the pectorals are supported by the pectoral girdle that joins the skull. So you are seeing here that the first spine of the dorsal fin, and we see here that this is the pectoral fin, which gets support from the pectoral girdle. So this is the pectoral girdle here. Which is getting support, which gives support to the pectoral fin. So we do have the many times caracoid. These are the radials. So we do have the abductor and adductor profundulus, which helps in the lifting the fish back and forth, left and right. So these are muscles which are responsible. So I mean to say that these very pectorals are supported by the pectoral girdle that join the skull. Now coming on to the adipose fins. Now I was telling you that many times there is a single dorsal fin, but many times an additional dorsal fin is present. We call it as the adipose fin. They are soft fins and are located between dorsal and the caudal fin. So this is the dorsal fin, this is the caudal fin. So those very fins which are located between the dorsal and the caudal fin, which call them as the adipose fin. So this type of the fin helps to navigate the fish in rough water, and it is mostly present in the case of Salmonidae, characins, and catfishes. So this is a kind of the this very fin, that is the adipose fin, which is the importantly found in the salmonidae, characins, and the catfishes. Then caudal fin. Talking about the caudal fin, it is the primary appendage which is used for the locomotion in many fishes. So a primary appendage which is found in many fishes. It is vertically expanded structure which is located at the caudal end of the body, and the base of the caudal fin is known as the caudal peduncle. So this is the caudal peduncle, I may be telling you. So this is the caudal peduncle from where the caudal fin starts, and so the base is called as the caudal peduncle with strong swimming muscles. So in general, caudal fin acts like a propeller. So this acts like a propeller, while the caudal peduncle, it functions as a motor. For example, this is the fish, and this is the caudal fin. This is the caudal fin. So if this is the propeller, and this here the muscles are present, their strong muscles are present at the base of the caudal fin. So this is the motor. So this acts as a motor and this acts as a propeller. If caudal fin acts as a propeller, then caudal peduncle functions as a motor. It is usually used to identify the fish species as well. The caudal fin also helps to identify the fish, because different kinds of fishes, they have the different types of the caudal fins. So we shall be talking about the modification just after few slides. So talking about the caudal fin, of the unpaired fins, the caudal fin is well developed in most fishes as it plays the most important role in forward propulsion during swimming. So this is the fin which is responsible for the forward propulsion. And the caudal fin in most of the fishes is highly developed with few exceptions. So in most of the fishes it is highly developed, but in some fishes it is reduced, such as hippocampus. In the case of hippocampus, that is seahorse, the tail is prehensile. And in bottom dwelling rays, the caudal fin tends to become reduced, and in stingrays the caudal fin is lacking. Because they are the bottom dwellers, they mostly use their pectoral fins for the swimming. So caudal fin exhibits different shapes in different groups of the fishes, and it is correlated with their habitat, so that it is of the great importance in the classification of the fishes as well. And in some fishes, such as you see here, that in some of the fishes, this is the caudal fin, and this is the caudal fin, it is the dorsal fin, and it is the anal fin. They all are joined together. They all are joined together to form the dorsal, caudal, and the anal fin. So let us talk about the important aspect of the caudal fins, that is the modification. That is how they are modified and what main types of the caudal fins are present. So first of all, it is the diphyscercal. We also call it as the protocircle. Then we do have the heterocircle, and then we do have the homocircle. Though there are modifications of these also, but basically they are of three main types, that is diphyscercal or the protocircle, heterocircle, and homocircle. So this is the kind which we call it as the protocircle tail. This is the primitive one, protocircle tail. This is the heterocircle tail, and this is the homocircle tail. And these are the modifications of the same. These are the modifications that we shall be talking about these. So this is the diphyscercle, this is the heterocircle, and this is the homocircle. So first of all, diphyscercle or protocircle. This type is regarded to be the most primitive type. It is not exhibited by many living fish, so it is the primitive type and not exhibited by the living fishes. So the vertebral column extends up to the tip of the tail. So what we see here, that the vertebral column is extending up to the tip of the tail. So vertebral column is extended up to the tip of the tail and divides the tail into two equal halves. That this is the one half, and this is the second half. Equally, just equal. The dorsal half, this very half, which is above, that is the dorsal side, we call it as the apicaudal lobe, and the lobe which is below the vertebral column toward the ventral side, we call it as the hypocaudal lobe. The apicaudal and the hypocaudal parts of the caudal fin are equal in size and are symmetrical. So this is the diphyscercal or protocercal. So this diphyscercal caudal fin occurs in modern cyclostomes, primitive sharks, holocephali, that is chimera, living dipnoid, that is lungfishes, living crossoptergians such as latimeria, and many larval teleost and deep sea fishes. So you have to keep in mind that this is a primitive kind of the caudal fin and is present mostly in cyclostomes, primitive sharks, holocephali, living dipnoid, that is lungfishes, crossoptergi such as latimeria, and many larval teleost and deep sea fishes. In chimera, what we see in the case of chimera or deep sea fishes, the caudal fin is isocircle. Why isocircle? That is equal, which is very much elongated and symmetrical. And if we look at the caudal fin of the latimeria, it is the extinct coelacanth. We call it as the extinct coelacanth. They have the unique symmetrical three-lobed tail with a marked median lobe. In living dipnoids, the caudal fin is protocircle type. That what does it mean? It means that this very vertebral column extends up to the tip of the tail, dividing the caudal fin into two equal halves, that is apicaudal lobe and the hypocaudal lobe. Now the another one, that is the heterocircle tail. Now heteros means different. Heterocircle caudal fin, it means different. It is the intermediate type. We call it as the intermediate type, in which vertebral column bends upwards. Now here what you are going to see, what you are seeing, that this very vertebral column, it bends upward, it is bending upward. Just look at this, that here what you are saying, that it is bending upward. It is not going straight, it is bending upward. So it reaches up to the tip of the more prominent dorsal lobe, thus making the caudal fin strongly asymmetrical. So for example, this is the fin. Herein what happens, the caudal fin, I will just show you in blue. The caudal fin, the vertebral column, it moves upwards up to the tip of the tail, but towards the elongated part and making the fin asymmetrical. The fin has two unequal lobes. Now herein what we see here, that the tail has not equal parts but unequal parts. That is apicaudal lobe, which is smaller one, the smaller apicaudal lobe, and the larger hypocaudal lobe. The hypocaudal lobe is larger and apicaudal lobe is smaller. Heterocircle caudal fin is characteristic feature of the bottom dwellers, with ventral mouth, without swim bladder. The strokes of the larger dorsal lobe in swimming serve to direct the fish towards the bottom. So these very fish, as they have to move in the bottom, so this very fish helps to make the strokes so that the fish serves to direct, this very fin serves the fish to direct toward the bottom. And it is the mostly the characteristic feature of the bottom feeders. Herein what you are seeing, that this is the heterocircle tail. And this type is found in the modern elasmobranchs. So most of the sharks, they have this kind of the heterocircle tail. Extinct osteolapid, crossoptergians, extinct dipnoids, and living holosteans, that is accipenser and polyodon. So you have to keep in mind that this kind of the fin is found in the modern elasmobranchs. We call them the sharks, skates, rays. Extinct osteolapid, crossoptergians, extinct dipnoids, and living holosteans. Holosteans, we do have the two important genuses, that is accipenser and the polyodon. The opposite of the heterocercal tail, now herein another condition is reverse to the heterocercal, wherein here in this very case the vertebral column moved upward, but in the opposite case vertebral column is moving downward, in which the vertebral column terminates into the larger vertebral lobe. So what happens in this very case? That vertebral column terminates into the larger ventral lobe known as the hypocercal, and the smaller apicaudal lobe. And this is seen in the case of the flying fishes, that is, we call them as the exocetus flying fishes. Homocercal caudal fin. Homos, it means common or alike. It is symmetrical externally, but internally it is asymmetrical. Now you have to keep in mind that homocercal, it is looking the same, it is looking common, but it is symmetrical externally, but internally it is asymmetrical. The posterior end, herein you are seeing this kind of condition. The posterior end of the vertebral column turns upward and becomes greatly reduced. Turns upward and becomes greatly reduced due to its tip. It does not reach the posterior limit of the fin, and there is no apparent dorsal lobe, but the ventral lobe is greatly enlarged. Ventral lobe is greatly enlarged and divided into two equal superficial lobes. And this is the advanced and the most common type of the caudal fin. Herein externally you see that it is divided into two equal parts, but internally you see that it is not divided equally, but it is moved upward and forming a ventral lobe which is enlarged, and the dorsal lobe, it is reduced. The homocercal caudal fin is characteristic of the higher bony fishes, that is teleos, and the most teleos retain the typical homocercal condition, but in some forms this condition is slightly modified. Now we shall be talking about their modifications as well. And we do have the different types of the caudal fins. Generally these variations involve special modifications of the vertebral column. The internal and the external structure of the caudal fin varies, which depends on the swimming habits of the fish. Then we do have the modifications of the caudal fins. That is, we do have the isocercal or leptocercal. We do have the condition, we call it as the isocercal or the leptocercal condition. This is the condition which is called the isocercal or leptocercal condition. And internally symmetrical caudal fin. We do have the pseudocercal caudal fin. We do have the hypocercal caudal fin. We do have the Giphyrocercal caudal fin. We do have the Giphyrocercal. We also call it as the Giphyrocercal caudal fin or Giphyrocercal caudal fin, but mostly it is pronounced as the Giphyrocercal caudal fin. Now, first of all, we shall be talking about the isocercal or leptocercal caudal fin. So, this very condition, isocercal or the leptocercal caudal fin, these are tapering and symmetrical types of the fin. And in this case, the spine is long. Herein you see the spine is long, which is a straight rod-like structure. Rat tails, anguilliformis, or featherbacks, that is notopteridae, and gymnarchids, they have the isocercal kind of the tail. So Blanidae, anguilliformis, notopteridae, gymnarchids, they have the isocercal kind of the tail. And the second condition, we call it as the internally symmetrical caudal fin. This is reduced type of the caudal fin where some fin elements are fused together. They are found in cords, mostly in the form of the cords, wherein some of the elements they are fused together. Then we do have the pseudo-caudal fin. Pseudo-caudal fin. In the modern lungfishes, that is Dipnoi, The pseudocaudal caudal fins are found. That is mostly it is the feature of the lungfishes. So in this case, the fins are developed from the backward growth of the dorsal and the ventral fins. So in this very condition, the fins are developed from the backward growth of the dorsal and the ventral elements. Then we do have the hypocircle. We do have the hypocircle, this very condition. We do have the hypocircle caudal fin. This type of caudal fin bears much larger dorsal lobe than the ventral lobe, which is greatly reduced. In this case, the vertebral axis turns downwards sharply where the lobe develops from its upper surface. They are found in certain early agnathids, and it is also called as the, I told you earlier as well, it is called as the inverted heterocircle caudal fin. So in the case of heterocircle, it moves upward, whereas in the case of the reverse heterocircle, it moves downwards, and it is also called as the hypocircle instead of the heterocircle. So it is found in the case of agnathin as well, that is the jawless fishes. Then we do have the Geophytocircle caudal fin. Geophytocircle. So it is a very specialized type. So this is the Geophytocircle caudal fin. It is a very specialized type of the caudal fin, which is also known as the bridge caudal fin. The caudal lobe is truncated. It is truncated where hypurals of the spinal column are lacking. So hypurals of the spinal cord column, they are lacking here. And these types of fins are found in pearl fishes. We call them as the carpus or phyraspher and Orthogoriscus. So this kind of fins are found in pearl fishes, phyraspher and Orthogoriscus. So this was all about the fins, types and their modification. Next time we shall be dealing with the sport fisheries, wherein we shall be talking about certain sport fishes and why they are called sport fishes, and what are the different gadgets and the devices which are used in the sport fisheries, and how sport fisheries help in the tourism, that we shall be discussing next. Thank you very much.